Let us take a look at this trigonometric function. Now, you're asked to find theta, the angle theta, between 0 degrees and 360 degrees. So I expect that you will find two values of theta. I want you to pause the video and go ahead and solve it. Okay, you finished? Let's look at it. Now, you have a 2 sine squared theta minus 4 cos theta equal negative 1.4. When you look at it, you see something squared minus something else squared. That means minus something else, or minus a number times something else. It has somewhat the looks of a quadratic function. Let me just add 1.4 to both sides to make it look more like that. 2 sine squared theta minus 4 cos theta is plus, I'm adding 1.4 to both sides, plus 1.4 equals 0. Now, it kind of, not looks like, and it look like 2x squared minus 4x plus 1.4 equals 0. But then the problem is, this should be x and x squared, alright? This is cos. This should be cos squared then. Same thing squared. Or it could be sine squared and sine. Alright? Now, we're going to have to make some adjustment so that we have sine and sine squared, or cos and cos squared. Now it's going to be much more convenient to change the sine into cos. Now let's look at this. What trig identity do you have involving sine squared theta? Remember, one of the basic trig identities, it says sine squared theta plus cos squared theta is identical to 1. Now, therefore, we can rewrite this, making sine squared theta the subject. So we have sine squared theta is equal to, I'm going to just use equal sign instead of identical. Well, no, not yet. It's identical to 1 minus cos squared theta. Now, when we go back here, we're going to go back to equal. So here, this is what we have. We have 2 sine squared theta, but sine squared theta is 1 minus cos squared theta. And if we leave out the sine square and put 1 minus cos square instead, then we would have cos square and cos. Alright? So part of our problem would be solved. So 2 times 1 minus cos squared theta minus 4 cos theta plus 1.4 equals 0. So you see that? Now, let's multiply out the brackets. 2 minus 2 cos squared theta minus 4 cos theta plus 1.4 equals 0, right? Alright. Now, let's put the 2 and the 1.4 together. We have negative 2 cos squared theta minus 4 cos theta plus 2 plus 1.4 equals 0. But then, this is 2 plus 1.4. It's going to give you 3.4. So let's just write it from now. That would be 3.4 equals 0. Alright. Now, you have a number times cos square and a number times cos. We want to see it as it is. It is a quadratic equation in cos theta. Alright? So what we have here is negative 2. Alright, let us say, simplify it. Let's simplify it. Let's call cos theta x. So, let cosine theta be equal to x and rewrite it with the x instead. Negative 2x squared minus 4x plus 3.4 equals 0. Alright. We could work with it as it is, but to start with a negative number, it's not that neat. It will be a bit less stressful on the brain if you get rid of these two negative numbers. So I said negative 2x squared. You just say start with 2x squared. So let's multiply it through it by negative 1. When you multiply it through it by negative 1, negative 2x squared become positive 2x squared. Negative 4x become positive plus 4x. Right? Plus 3.4 becomes minus 3.4 equals 0. Alright, nice. Another thing. These points, when you're working with points, you probably would want to work with whole numbers instead. Right? Less stress. So if you multiply everything by 10, you get 20x squared plus 40x minus 34 equals 0. Oh, guess what? You could divide, if you probably have multiplied by 5, you could divide by 2 here. So you have 10x squared plus 20x minus 2 into 3 goes 1 times 1, 2 is 14, 7. Yeah, equals 0. Good. You have whole numbers, even though they are bigger numbers. The thing is, you could have solved it with this, right? But I'm just thinking of using numbers without those points business. All right. Now, you could possibly you could use the quadratic formula to solve this quadratic equation. Well, let's do that now. X equals negative b, which is negative 20, plus or minus the square root of b squared, which is 20 squared minus 4, times a, which is 10, times c, which is negative 17, all over 2 by 10. So that will give you negative 20 plus or minus the square root of. Now it's going to be 20 squared, which is 400, plus 4 by 10 by 17 equals, is going to be 1080 over 20. So x equals, now what's the square root of 1080? You have 32.86. Alright, so 32.863. So negative 20 plus or minus 32.863. I'll put it to 3 decimal places because it's a good thing to put to at least 3 decimal places until you're finished. Alright, this is over 20. So you're going to have two values for x here. X equal, now when you have negative 20 minus 32.863, 0.863, and then you put that over 20, you're going to get negative 2.643. Negative 2.643. And the other value is when you say negative 20 plus 32.863, and then you put that over 20, and you get 0.643. Now, the thing is, what was x equal to? Again, let us see. Oh, cos x. I mean x equal cos theta, not cos x. Cos theta right here. This is saying that cos theta is negative 2.643. Now remember, the cosine, it doesn't go above 1 or below 1. This will be out of range. So this one would be undefined. That is an undefined function. Alright? Now, the other one, cos theta is equal to 0.643. That can work. So now theta equal cosine inverse of 0.643. Theta is, so we're going to find the cosine inverse of 0.643. So we have 0.643. We want the inverse cosine. I'll put the 0 there. So the way it is done on this calculator is to say cos and then inverse. We get, call it 50 degrees. It's about 50 degrees. We get that. But then remember, you're asked for the angles between 0 and 360. So I expect a second angle to be there. Let's see what that second angle could be. Let's get a circle. And we're going to use the unit circle. Alright? Now, let us have the circle divided into 4 quadrants, 4 parts. You know, the first quadrant is 0 to 90 degrees. The second quadrant is 90 to 180 degrees. The third quadrant is from 180 to 270 degrees. And the fourth quadrant is from 270 to 360 degrees. Now, our 50 degree angle, let's call it this. So we have 50 degrees. Now, here is it's a right angle triangle that you really have here. And we found the cosine of the angle to be 0.643. We find that it is 50. But remember, cosine is the adjacent divided by the hypotenuse. Alright? Now, let's look at this. What is another triangle that gives you the same adjacent? Well, it would give you the same hypotenuse too. Now, here, if you consider this triangle, remember this angle here would also be 50. But the angle that you really should be measuring is from 0 in an anti-clockwise direction. So this angle now that angle right there would be 180 degrees. You go all the way to 180 and then you back off 50 from it. Now, I don't expect that this will be one of the angles. Why? Because if you find the cosine of this angle, it will not give you a positive 0.643. It will give you a negative 0.643. The reason is because this adjacent is the same length as this adjacent. But guess what? This adjacent goes to the left in the negative direction. So you have a negative adjacent over a positive hypotenuse. Now this is 130 degrees. Now I expect that if I find the cosine of 130 degrees is going to be negative 0.643. So this is not going to be one of the angles. I know already now, but just going through the calculation just to ensure that you remember exactly what is going on here, how to deal with this situation. Now, 130 cosine of 130 equal as negative 0.643 to 3 decimal places. See that? Now guess what? I am sure that if you find the angle in the third quadrant, it will also be a negative 0.643. What will that angle be? Let's say we start here and we go all the way around right here. Remember, this is 50 and this is also 50. It's a similar triangle. Now, you have the adjacent, same adjacent as over here, over the hypotenuse, same hypotenuse, because the hypotenuse is the radius of the circle, so it doesn't change here. But this angle would be 180 plus 50, which would be what? 0, 0, 0, 8, 9, 10, 11, 12, 13, 3 carry 1, 1 and 1, 2. I bet you that if you find the cosine of 230, you're going to get negative 0.643. Well, let's try cosine of 230 degrees and see what's going to happen. Cosine 230 equal negative 0.643. See that? Always works. Now, I know what the correct angle will be. And it will be an angle in the fourth quadrant. Let us draw another triangle, this time in the fourth quadrant. Now this angle here is 52, you know. Now, guess what? If you start from the center, the adjacent for this triangle is to the right. So it's a positive adjacent over positive hypotenuse. Hypotenuse is always positive. Since it is the same adjacent and the same hypotenuse, I expect to get that angle having a cosine of 0.643, and it will be positive because it's a positive adjacent over a positive hypotenuse. So let's see what happens. That angle, to get that angle, you have to go all the way around to 360, then you back off 50. So 360 minus 50, 6 minus 5, 11, I have 3. 310 degrees. Now, let us see what the cosine of 310 degrees will give us. That should be interesting. Cos 310 equal 0.643. So we got our second angle, it's 310. So what you can say, there are two values for theta. You can call one theta 1 equal 50 degrees and theta 2 equal 310 degrees. So there you go.